Let's talk about arithmetic sequences. An arithmetic sequence has a common difference between your terms. So these are ones that are adding or subtracting the same amount between each term in the sequence. For example, 2, 4, 6, 8. Your first term in the sequence is 2, and then your common difference would also be 2 because you're just adding 2 each time. Another example would be -3, -6, -9, -12. Your first term, we call that a sub 1, is -3, and your common difference is -3 or subtract 3 because that's what you're doing each time. It's common, so notice it happens every time. This is not one of those questions that used to be asked like a pattern, like find the pattern in the sequence. These have a common difference, so it should be the same thing every time between each term, or it does not fall in this category. We have two forms for arithmetic sequences. We have recursive form and explicit form. Recursive form is a sub n equals a sub n minus 1 plus d, your common difference. So I've defined the variables down here, so you can add those to your notes. A sub n is a term in the sequence. We usually call that like the nth term, the one we're talking about. A sub n minus 1 is the previous term, so it would be considered the one right before the one you're talking about. And d is the common difference. So let's look over here at explicit form. Sometimes you need recursive and other times you need explicit. So explicit form is set up as a sub n equals a sub 1 plus n minus 1 in parentheses times your common difference. So a sub 1 is your first term. A sub n is the same as it was over here, so I didn't write that twice. That's a term in the sequence you're talking about, or your nth term. And n is the number of the term you're talking about. So when you plug in this n right here, it's equal to that n. So if you're talking about the 34th term, for example, you're talking about a sub 34, and you will plug in 34. But we'll look at that with some examples. So let's see. Let's look at this example. Using the given data set, write the correct sequence recursively and explicitly. So if we're given 2, 5, 8, 11, 14, and 17, what do you notice is happening between each term? So you probably notice that between 2 and 5, you add 3. And the same thing between 5 and 8, 8 and 11, and so on. And you notice it happens between every single term. It's important to check all of them when you're given a specific problem. So for your recursive form, this is the one that's really simple. It's very similar to the now next equation you might have seen before. So a sub n, any term in my sequence is going to be the one before it plus 3, because that was my common difference. So the difference was a positive 3, and a sub n will just be a sub n minus 1 plus 3. So any term in my sequence is equivalent to the one before it plus 3. So that should make sense. So we could say in our old terms, next would equal the one you have now plus 3. That might look familiar. All right, so let's look at explicit. The explicit form, we have the common difference was 3, and we're going to put in our first term. So this one has 2 for our a sub 1. So I'm going to draw a little arrow. That is a sub 1. It's equal to 2. The common difference was 3. So we would write out a sub 1 is 2 plus n minus 1 times the common difference of 3. So here we could simplify that into slope-intercept form if we wanted to. But we can use this form to find any term in the sequence. So I can start from anywhere. If I want to find the 71st term, I would just plug in 71 right there, where this one wouldn't be as helpful unless I had the 70th term, because then I wouldn't know what to add 3 to. But this one would help. Let's look at some more examples on the next board. Okay, so what if we're asked to determine if the sequence is arithmetic, and then if it is, find the common difference and write it in recursive form. So we're just looking for what's going on between each term first. So 35, 32, 29, 26. So from 35 to 32, we subtracted 3. And then from 32 to 29, we also subtracted 3. So you're just making sure that happens every time, and it did. And so you have the common difference. So your recursive form would be a sub n is equal to the previous term minus 3. So the term you're looking for is the one before it minus 3. It's very simple. Very straightforward. So it goes directly with your common difference. Negative, let's look at number 2. Negative 34, negative 64, negative 94, negative 124. These are definitely decreasing by 30 each time. So we would say our recursive form would be the previous term minus 30. Let's look at number 3. We have 5, 4.25, 3.5, and 2.75 because you can have decimals and sometimes you could have fractions, but they work with the same idea. So 5 to 4.25 would be to subtract 0.75. So the same thing happens between 4.25 and 3.5. And then the same thing happens again. So that is our common difference. We would say the term we're looking for would be the previous term minus 0.75. Let's check out number 4. We have 9, 13, so we had to add 4, but then 13 to 18, you would have to add 5, and 18 to 24 would add 6. So this is one of those old ones where you used to have to figure out the pattern, but this is not an arithmetic sequence because you're not adding the same amount every time or subtracting the same amount. So let's look at one more board. Okay, this one wants us to find the indicated term of the arithmetic sequence. So sometimes you're given the sequence and sometimes you're given direct information about the sequence. I'm going to switch colors. So if I want the 17th term of this sequence, I would use the explicit formula for these, and I would easily see that my first term is 0. My common difference looks like it's increasing by 5. So D equals 5. So to write out my explicit formula, any term in my sequence would be the first term, which is 0, plus n minus 1 times that common difference of 5. So they've asked for the 17th term. So a sub 17 would equal 0 plus 17 minus 1 times 5. So you just clean that up. 17 minus 1 is 16, and 16 times 5 would be 80. So the 17th term just equals 80. Let's look at number 2. The 42nd term of this sequence, so we know that's the first term. That's very easy to spot. Came first. And then the common difference is that it is increasing by 0.25. You don't have to write a positive sign. Let's just make it a positive number. Okay. So our explicit formula would be a sub n is our first term, 0.25, plus n minus 1 times the common difference, which in this case is also 0.25. We're going to plug in 42 for our n. So a sub 42 equals 0.25 plus 42 minus 1 times 0.25. And you can clean all of that up to tell you to get for yourself that the 42nd term, and I've already worked it out ahead of time, should come out as 10.5. So sometimes they could be decimals. Number 3, not 95. Let's look at this one. They gave us direct information this time, so I can fill in that the explicit formula would be the first term plus n minus 1 times the common difference, which is negative 0.7. So I'm multiplying that. And I want to plug in 95. I want the 95th term. I keep trying to put that decimal in the wrong spot. Okay. So then I've worked that one out ahead of time. When you clean all that up, you end up with negative 129.5 for your 95th term. So these are some examples of what you might be asked. There are lots and lots of ways they can ask you questions.